welcome to the School of Forest Resources and within the College of the Environment. We're in our 10th month of a new birth in pulling a group of different departments and schools together. And I think that if I looked at the list of people that are attending today and the diversity of topics that they're interested in, I think it's a perfect reflection of the sort of broadening of all of our visions. So welcome. I just want to very quickly frame a number of issues that I think will be covered in today's series of papers. And I've used this particular slide as sort of as a way of illustrating sort of, I think, maybe a value or a vision that many of us have for the Puget Sound region. From the water, in essence, from the white caps to the white tops, this is a special place on the globe. And I think many of us see value in retaining certain elements of that place and understanding the pressure that those elements may be coming under and what we might do in terms of solutions. And we come at this from a whole range of perspectives, and I think that range of perspectives make for a very healthy discussion. So today's talk will be outlined around a number of themes. Three first talks will talk about the problem, and then the next sort of two sets of three talks are from a range of different perspectives, and they deal with those perspectives and solutions to the problems that have been outlined. So I think the context in which this discussion is thinking in terms of healthy forests and healthy forest landscapes, and the definition of health spans from the ecological to the social and economic. And this is a picture of spruce budworm devoured grand fir on the east side of the Cascades, and even though we're just dealing with the west side, I think the forest health issues span. We're also thinking about the goods and services that forested systems provide, whether those are cultural or spiritual or recreational services, or are they monetary services. We're thinking about the broad suite that these things provide, and so there's a universal sense that the services that they provide have more value than, say, a shopping center. Let's just sort of frame it in that way. And then hopefully that gets reflected in the water quality, air quality, the quality of life that is in this particular state. So thinking of healthy people, thinking then in terms of these things, in terms of climate change and the impact that climate change may have on these systems, and even on what's now been termed climate refugees. So people from other parts of the world that might see the stability we have in the Pacific Northwest as a place to migrate to or immigrate to. Population increases in the area. And then I would also like to recognize the Denman Endowment for making these conversations possible and important. So one other sort of contextual thing is sort of the idea of reference points. So where do we, in our discussion of a system, whether it's an ecological system or a human system, what point do we use as a reference frame? And so here's an old-growth forest. Might have been a vision that people had in 1928 of this old-growth forest. And then, if you grew up in the 1990s, this might be your view of what an old-growth forest looks like. It's already changing in scope, but now this becomes our new reference point or our new baseline. And then as we continue in 2028, this may become our reference point. So the point is that in thinking about recovering systems or monitoring systems, you need these kinds of reference points to come back to. So we're going to explore this, and I welcome your participation and comments as we move forward. Thank you very much.
So our first speaker is Tim Quinn, who is the Chief Scientist for the Habitat Program at the Washington Department of Fish and Wildlife and is Chair of the Puget Sound Partnership Science Panel. So, Tim.
Well, first of all, thank you, Bob, for the invitation to come and talk to you today. It's good to see a lot of familiar faces. Haven't been up to the U for a while. I want to provide a sort of high-level overview of the environmental conditions of Puget Sound. I want to talk a little bit about natural systems, a little bit about human systems. First off, let's get a little bit of the physical setting. It's probably best to think of the Puget Sound ecosystem as part of a larger Salish Sea ecosystem that stretches across two countries there, Canada and the United States. It has been shaped by fairly dramatic forces, including volcanism, glaciation, and plate tectonics, and a lot of smaller scale, more recent forces such as flooding, forest fire, and wind throw. There's a fair amount of environmental heterogeneity in the ecosystem, and that translates into a fair degree of biodiversity that has been recognized by the World Wildlife Fund. The ecosystem is one of 200 priority ecosystems for worldwide biodiversity by virtue of its globally outstanding ecological phenomena, and I'll explain that in just a second. It's also been recognized by the Center for Biological Diversity as a significant national biodiversity hotspot. So here's just a short list of some of the global outstanding ecological phenomena. We're still part of the world's largest remaining temperate rainforest. Our forests are particularly productive, on par with tropical wetland forests, at least seasonally. We have a large estuary. We're the second largest estuary in the United States, second to the Chesapeake Bay, and we have a unique assemblage of marine biota relative to the Pacific Ocean. We have high salmon productivity. And what that means here is that we have high species richness, 6 species of Pacific salmon, which also includes the steelhead, and relatively large populations of each of those. We have the second largest oyster production in the US, and we're the largest clam producer on the West Coast. We have our share of iconic species, Chinook salmon, geoduck clam, which puts us into that clam production category, northern spotted owl, southern resident killer whale, and some of our, or at least one of our trees in our forest. At least 3 of those iconic species are listed under Endangered Species Act. When Captain Vancouver arrived in 1792 in the lower part of the Salish Sea, he promptly named that lower portion after his lieutenant, Peter Puget, and claimed the area for Great Britain. If you take a look at the map on the left, those are territories defined by linguistic groups of the Coast Salish Sea people. The area was inhabited by many different local groups, linguistic groups, where they occupied a lot of the nearshore areas and lower portions of the river estuaries. The early history of the Puget Sound ecosystem is similar to early histories elsewhere in the United States. The folks that came out were adventurers, entrepreneurs. They came out and they lived off their own wits. There was plenty of natural resources for them to take advantage of. Salmon was a big one, but they also were hunters and trappers, and they also lived and learned from the Native American people how to harvest sea creatures. And there was an immediate discovery of the Olympia oyster as a substance or as a main staple. Logging begins in the 1850s, and it was mostly done by horse and axe. Not an easy task to fell some of the large trees that were abundant in the area. Logging really got a large charge from California Gold Rush, where lots of people were coming out to the West Coast and settling in rapidly built towns. There was a high shipping trade where shippers came up and took timber and brought it down to California. Most of the harvest activity in these early years was focused on the nearshore areas, both of rivers and the marine areas, and it was largely related to the fact that in order to move the timber, you needed to get it in the water. It was difficult to move it with other means. The first dikes were built in the 1860s. If you were a farmer or thinking about farming when you came to the Pacific Northwest, you had really 2 options. One, you could think about trying to farm in between the big stumps or trying to remove those 12-foot stumps, or you could go to the estuaries of some of the major river systems, and there all you had to do was build a dike that prevented inundation from salt water. So it's been said by about 1900, nearly 20% of the wetlands in the major river estuaries was already under dike and in agriculture. As early as 1874, the Olympia oyster was becoming depleted. People were lamenting the loss of this natural resource, and people started importing Pacific oyster, which tended to be a little bit more robust and grow a little bit faster under the climatic conditions in the Puget Sound. In the 1890s, 1880, the Transcontinental Railroad was connected, and then by the 1890s, the railroads were up and accessing upslope timber supplies. A lot of these were built in the river valleys, or the river bottoms, and along the shorelines. Most of the transportation of timber was done via salt water, so the development of the shoreline was viewed as critical to development of the Pacific Northwest. By 1890, Washington was one of the 5 top timber producers in the U.S., and it had increased salmon productions or salmon landings by 2,000% over catches 2 decades earlier. So the railroads really ushered in this, the first of the technological revolutions that were really going to start to transform the Pacific Northwest. Washington became a state in 1889, and the state constitution recognized the role of entrepreneurship and what I call a frontier governance model. It had limited state government. It tended to distribute power to local groups, local communities, local jurisdictions. Its belief in private property ownership in combination with natural resources was the economic engine, which was going to make Washington great. And to that end, the first legislature of Washington allowed for the state to dispose of state-owned title lands. That practice continued up to 1970. About 60% of the state-owned timberlands were sold during that period of time. Again, a lot of this was deemed as necessary to develop the area. Let's talk briefly about the state of the Puget Sound ecosystem, the natural system here. There's lots of different ways you can characterize some of the effects that humans have had on the ecosystem. Here's a few of them. 60 to 90% of the old forests have been harvested, depending on whose estimate you want to believe. 23% of the forest lands have been converted to other uses, mostly agricultural and urban development. 52% of the marine shoreline has been modified. A lesser degree has been armored with hard armoring. Nearly all of the marine shoreline is platted. 81% of the tidal wetlands in those major river estuaries are lost. 25% of the watersheds have been over-appropriated. What that means is that at certain times of the year, there's not enough water in those rivers to supply fish and wildlife and human uses. Again, one estimate says there's 285 critically endangered species, 4 globally extinct, 2 species of pocket gopher, milk vetch, and bugbane, 2 words I learned for this talk. 25% of the plant species are threatened with other invasive species. This pattern of human development on coastal ecosystems is pretty consistent worldwide. We tend to develop near waterways because of the beauty, because of the access, because of the transportation, because of the recreation, and Washington State is no different. You can see some of these legacy effects from the early development. The railroads, we have one of the largest railroad lines that runs on the east slope, or on the east shore of the Puget Sound, basically from Seattle up to Everett. Unfortunately, these are also some of the most productive areas, so we've tended to settle and disturb most of the productive areas, or a lot of the productive areas in the Puget Sound. One of our iconic species, and one that I would say was responsible for the development of the Puget Sound, the King Salmon, has declined precipitously. If you can't quite see that, there were estimates of somewhere around 700,000 King Salmon historically, and we're down around 51,000 or so. The orca was listed as endangered in 2005. We've increased the frequency and severity of dead zones in Hood Canal. Dead zones are areas of low oxygen concentration that happened historically. They produce these rather startling fish kills, which garners them lots of attention in the newspaper, increases in nitrogen input from septic tanks and potentially from alders replacing conifers in drainage basins has exacerbated the dead zone phenomena. We have a number of legacy effects associated with toxics. We have about 1,500 sites representing 1,600 hectares. Most of these toxic sites are located in urban bays. About 50% of those sites have been attributed to point sources where there was a particular industry that discharged there. The other 50% are from a far more nefarious source, and that's non-point source pollution. And we have these occasional episodes where the newspapers get involved. This was a recent whale that was found on one of the Puget Sound beaches, and I thought I would quote for you what they found in its stomach: a surprising amount of human debris, 20 plastic bags, small towels, surgical gloves, sweatpants, plastic pieces, and duct tape. So let's talk a little bit about the human system if we can. In 2006, in preparation for the development of the Puget Sound Partnership, the partnership sponsored a survey where they went out and asked Puget Sound residents a series of questions. And what they found in that survey was that the public was largely unaware of ecosystem service decline. 73% of the public surveyed rated the environmental health of Puget Sound as pretty good or excellent, and not surprisingly, transportation was the top regional issue. It included things like traffic volumes, price of gas, commute times. On the other hand, in the same survey, when they told people that Puget Sound was in trouble, this is how they responded. 68% of the populace said that growth and development were the major threats. 84% believed that we could not restore Puget Sound, but also in doing what was necessary to prevent further degradation. The best cited reasons for improving Puget Sound included responsibility to future generations, need to protect fish and wildlife, and human health, and it's good for the economy. I've bolded those last two because of the human connection, and I'll come back to that near the end. So what's new in the effort to restore Puget Sound? Well, first of all, you got to ask, who's responsible for Puget Sound? And the short answer is just about everybody. This is a list of entities and jurisdictions that have some stake or some responsibility in managing Puget Sound. And I don't think the Atlantic cod food web model that I've used to demonstrate this is quite as complex as what it takes to manage Puget Sound. So the Puget Sound Partnership was formed in 2007. The Puget Sound Partnership was the third state agency formed to try to deal with the problems of Puget Sound. The partnership was defined as a community effort of citizens, and the order of this is important. Citizens, governments, tribe scientists, and businesses working together to restore the sound. And to oversee its restoration by 2020. It was founded on three major beliefs: that Puget Sound is a national treasure, not just a state treasure. It was in serious decline that was likely to worsen through time, and that the current systems of protections and the current strategies to protect the Puget Sound were largely fragmented or uncoordinated and mostly ineffective. There were 6 goals stated in the Puget Sound Partnership's authorizing legislation: maintain a healthy human population, maintain quality of life for humans, and then maintain native species and their habitats, water quality and quantity that support both human systems and natural systems. What's really new about the Puget Sound Partnership? If there were 2 state agencies that had tried and failed, what was new about the Puget Sound Partnership was that it was a comprehensive approach. It wasn't going to deal just with water quality issues when it finally hit the water bodies. It was going to look upslope, and it was going to deal with land use from the white caps to from the snow caps to the white caps. It also explicitly considered coupled human and natural systems, and which would involve an analysis of trade-offs in ecosystem goods and services. So it made explicit this idea that you can't have everything, and that what you do, your actions will influence what the ecosystem can provide for you. In an effort to put a finer point on this system of trade-offs, the partnership hired the World Resource Institute to do an ecosystem evaluation of the Puget Sound. And I just wanted to go through this really quickly. They tended to put a fine point on this idea of trade-offs by saying, and this is just 2 bullets out of a list of a lot of bullets, but there would be competition for land and shoreline resources, and there would be competition for public access to forest, shorelines, and marine environments. Let me tell you what they said further about that. So this is just the forest piece. Basically, they said, listen, the trade-off boils down to something very simple. We don't need to make this more complex than it is. But forest lands provide these ecosystem services, and residential land provides very few ecological systems or services. So the take-home messages. Humans benefit from ecosystem goods and services and have increasingly affected the capacity of the ecosystem to provide those services. Many of the changes that we're seeing today have historic roots and apparently are barely visible to the public. In other words, the public doesn't really see what's going on. Bill Ruckelshaus suggests that unless your waterway is on fire, the public is not going to be paying attention. So if you look out on Puget Sound, everything looks hunky-dory. The authority to effect protection and restoration is diffuse and localized. So whatever solutions you have to deal with this issue. In other words, you're not going to top-down regulate recovery of Puget Sound. And recovery may be more about natural than social science.
Okay, so our second speaker is Rob Harrison, who is a professor of forest, soil, and environmental sciences in the School of Forest Resources at the University of Washington. And today he's going to talk about forests and the health of Puget Sound. How do soils contribute to the problems and solutions? Rob.
Okay, thanks, Bob. And so my charge today is to make you realize that soils are an extremely important part of not necessarily the problems with Puget Sound. It's the way we use our soils that have created the problem, but also looking at our soils and understanding them and working with them as a part of the solution for the problem. And if you consider Puget Sound itself, one of the things is you have to worry about your perspective on it. You can take the total blue water perspective where Puget Sound is nothing but water, but it wouldn't be it wouldn't be a bay or a sea if it didn't have an interaction with the land. So as we increase our perspective, we start to see, yeah, there is land there. Increase it a little more, the land becomes a fairly large part of the whole. And if we increase our perspective to include, pretty much all the water that flows into the region, and I don't have an outline across around the whole area, but we see that actually the land itself is a major part of the Puget Sound. So if we consider water that falls into the ecosystem or eventually winds up in there, it could fall directly on water, but most of it will fall onto the land first and then interact with that to some extent, eventually moving into the Puget Sound ecosystem as fresh water diluting salt water. And that's really what makes it such a magical system. But keep in mind that most of that water falls on the land first, and then either interacts with the soil, it can run off quickly, or it can enter the soil and interact with it. And that has a lot to do with the timing and the quality of water that's going to enter the Puget Sound ecosystem. So we need to know what soil is. Soil in general is an unconsolidated material on the surface of the earth. It's not rock. It can derive from rock. But more important than that, soil is the material that stuff grows in. And it's the home for a lot of ecosystems. Tremendously more biodiversity than anything above ground. 10 times at least more biodiversity in the soil. But it doesn't generally have fur and fins and things like that, so it's not as exciting to most people. Things that rely on soil range from microbes to really, really big organisms medium-sized organisms like giant Douglas fir trees, to really large organisms like fungal hyphae that permeate through many hectares of land and probably are the largest organisms. However, we should think of soil as a provider of ecosystem services primarily. And if we generalize, we couldn't cover them all, just like we can't consider all aspects of soils, but if we consider the main ones, it's the capacity to affect infiltration into the soil of water. When water hits the land, it can run off immediately, hit the streams and rivers, and wind up flowing into Puget Sound quickly. It can move a lot of material, including pollutants and pesticides with it, or it can move through soil, be filtered, attenuated, and gradually make its path into the streams and rivers and into Puget Sound. And that timing is just as or more important than the quality of the water. Soils also store a lot of water. This is extremely important. In many cases, fully half of the water that hits the land is actually held in the soil and evapotranspirated back up into the air through the growth of plants. If we change that water flow path, in many cases our ecosystems can run out of water. If we look at the endowment we have in terms of the landscape in the region, we notice the north-south orientation. That's because of the glaciation. We have a pretty impressive geography and soils in this region. The glaciers came from Canada. They're one of the original gifts from the Canadians. And the north-south effect of the gouging of those glaciers is very obvious in Lake Washington, which is approximately north-south oriented. This part of Puget Sound, okay? And then also Lake Sammamish and further east Pine Lake, for instance. Those glaciers had an enormous impact. The whole Puget Basin was completely filled with ice. No water flowed in its normal pathways as it does now during that period of time. It was all shunted south out through the Chehalis River. And it must have been a pretty impressive river that flowed in those days when the Puget region was completely full of glacial ice. At the point right here, at the maximum extent, there was about 3,000 feet of ice. Interestingly also, we worry about a few inches or feet of ocean rise with global warming, mainly because we have a lot of stuff there now. But the oceans dropped fully 100 meters by some estimates, 300 feet, and then have risen that in the last 10,000 or so years. So that's the kind of thing that can actually occur. We see all the evidence of that in our soils, in our landscape. Notice that when glaciers move, they're not pure crystalline ice generally. They're integrating themselves with the land. They're grinding up the rocks, they're moving them, they're depositing that material, and that becomes soil. And the two main properties I'm going to cover, the effects of these glaciers, are what got deposited that became soil, and the glaciers sorted it out when they melted, they washed the fines out, they left the very coarse material, and then also the impact of that pressure from the ice, which can compress the soil and affect the ability of water to enter the soil, be attenuated in it, and then gradually make its way to Puget Sound. So coarse textured soils transmit water rapidly. Fine textured soils tend to have it run off. No big surprise there. This is because of the pores. And then any pressure and compaction from the glaciers tends to also squeeze out pore space, so it would tend to encourage water to run off. And these things are very obvious naturally in our soils. So first I'm just going to cover natural soil properties of some very important soils. Everett is a very coarse, gravelly outwash soil. Water flows rapidly through it. The storage is very low. It's an infertile, low productivity soil. My backyard, Indianola, and a lot of the soils in the Arboretum are this. It's also a coarse, textured outwash soil, very important. Water flows rapidly through it. Okay, storage is low. Kitsap are the fine materials that settle out in the bottom of glacial lakes. Probably the closest natural soil around here would be a kitsap. And in the Arboretum, Foster Island, there's a lot of this. Just because of the natural properties, runoff is high, infiltration is extremely low, and when water can enter the soil, it tends to be held readily. Seattle is an organic soil, but nearly all the Seattle soil in the region has been affected, at least in the city and in the region, because it's either been cleared for agriculture, it's been drained for agriculture, or it's been filled in. Alderwood, the most common soil in this part of Washington, and probably the most abundant soil in terms of feeding, is a highly compacted glacial till deposited directly by ice. Its infiltration is variable. This is the most developed soil currently. Nearly all the substantial development is going on in this particular soil because of its stability properties and also because of its abundance. I want to compare quickly an area, in this case Redmond Ridge area, a native soil and the properties it would have, which if we look at runoff, what we have is the water would fall into the natural landscape. A lot of the water would infiltrate into the soil, gradually make its way through the soil and groundwater and into the stream. Very little immediate surface runoff. And then a lot of that water is held in the soil and transpired back through the plant stomates back into the atmosphere. That's considered the baseline, which we started with a lot of our soils. If we go adjacent up here on Redmond Ridge, for instance, okay, into a development, we see what happens in many cases. In this case, the surface soil was completely removed. Areas were compacted, and this makes for fantastic footings for buildings and road surfaces and so on. But also the lawns were greatly affected as well. So what we have in the case of an urbanized soil is a change in the water flow paths. There's more runoff directly because the soil's been hardened or directly covered, less water infiltration into the soil, and then less evapotranspiration. Oftentimes the new ecosystem has a lot of grass, but often a variety of other plants. Oftentimes it actually has to be supported with irrigation. A large part of that is because the water hasn't been infiltrating and stored in the soil, or the surface soil, which is permeable, has been actually removed. So what we do when we go to a system where we've hardened or reduced the permeability and water storage of the soil is we have an original, like the green area here, an original zone of water flow where a particular rainfall event is going to result in an increase in flow of water in the streams, lakes, eventually fresh water that dilutes the salt water and contributes to Puget Sound. And that timing and amount of material is critical to maintaining what we, the estuary system. What happens is a lot of it's held in the soil, and then when there's no rain, the runoff comes gradually out and maintains relatively high stream flows, okay, even when it's not raining. An urbanized system, the water flows rapidly, carrying any surface chemicals that are picked up or material that pieces of soil erosion, things like that, rapidly entering the fresh water, moving rapidly into Puget Sound, and we get a very high temporary dilution. Then after the rain stops, the water flow stops more quickly, and then we get a higher amount of salt water, less fresh water diluting the saltwater ecosystem or the brackish ecosystem. Conversion of forest in particular hardens landscapes. We see, for instance, that many of those are just plain covered with impermeable surfaces. But probably more important, most of it is left with what appears to be soil, but is highly altered. So in many cases, what we've done is we've compacted or even removed the permeable soil. And in this case, we've laid, this is several years after the application of turf, and it still hasn't rooted into the soil at all. You can just sort of peel it off. So the term that Redmond applies to that is turf on till. It's not something at a restaurant. It's actually a phenomenon of a very hardened soil. The hardened landscape has water rush off much quicker, and this results in higher erosion, lower summer flows. These are all things that are not good for one of the primary Puget species that we really like, is salmon. And salmon, of course, is a species that also feeds orcas and other. So these particular kind of conditions are not amenable at all to the health of Puget Sound for a variety of reasons. Here, for instance, is the flooding of the Cedar River. Now, don't get me wrong, a lot of this is natural, but what's happened is when we harden the landscape, we cause these events to be much greater, and the effects, the negative impacts of that to be much greater as well. Here also, these effects on soil and land cover can result in material directly depositing itself into Puget Sound. Of course, we have an altered shoreline to begin with here. This is north of Edmonds. And in this case, the removal of vegetation and probably mostly the change in water flow paths have resulted in a slope failure. Again, a lot of this stuff happened naturally. It's just been accelerated by a lot of things that people do. Here's Perkins Lane, which moves right into Elliott Bay. And yes, it is moving right into Elliott Bay, along with many of the homes that were along there. And what's actually happened here is the city of Seattle is pumping in a lot of technology to try and remove water and actually change the water flow paths, in many cases successfully. People in Perkins Lane will notice an extra charge for water management, for instance, including many of the people along Puget Sound and Lake Washington. So our needs are, first of all, to try and quit urbanizing soil in the first place. And where we can't do that, or where it's already been urbanized, we can actually potentially recover some of that better flow properties and better chemistry and biology of the water that enters the greater Puget Sound ecosystem. If we can increase water percolation, decrease runoff, we also decrease erosion. We get a lot of the positive impacts. If we actually have our plants rooting in soil instead of sitting on top of them, we wind up not needing as much fertilizer. We don't need summer water. But on the other hand, in order to get our forests and our plants to grow, they do need to have nutrients. They do need to have water. But that ideally would be kept in the site, in the soil, in the terrestrial ecosystem, and not moving in large amounts into the Puget Sound brackish water ecosystem. Just outside of CUH here, there's a study. If you walk toward the west there, you'll see these. These are studies where we actually, along with Steve Burgess in civil engineering, he's the main person on this, we actually took till very common soil in terms of its development and created a very common slope with it, and then amended a soil. In this case, it would be an alderwood material, a till soil surface, and we actually amended that with compost, and then followed the water flow. Underneath of those, we have these things called tipping buckets, which monitor the surface runoff and the subsurface flow. So we know when the water hit the site in rain, or we added it with irrigation, and we know whether it flowed off the surface, we knew whether it flowed through the subsurface, and we knew the time and quantity of each of those. One of the things, we have 2 events here, and what we've done is we've added water, something on the order of a 50-year return interval rainfall event, which of course doesn't ideally happen very often, and then followed what happened. The bottom line of this is that, and I'm going to point here, is that we reduced the runoff in a 24-hour period. Here's the non-compost amended, here's the compost amended, and we nearly doubled the amount of water that was held in the soil from that rainfall event. This would be water that doesn't quickly move into the streams and lakes and rivers and into Puget Sound. It would also be water that was held on the site and can be evapotranspirated, so it never entered Puget Sound as fresh water in the first place. The Street Edge Alternatives, the C Street program, is designed to do this with runoff from our roofs and streets. And another good impact of this is the soil filters the material, so the water that does eventually make its way out of that is of higher quality. Key is the timing, the quantity, and the quality of the water here. So again, what we're trying to do is we're trying to take those rainfall events and in some cases move an urbanized landscape back closer to the original. Maybe not get all the way there, but any way in which we can move it back closer to the original water flow passes is a positive. Key to this, most of that water that enters the Puget ecosystem hits the land first, most of the fresh water. It doesn't fall right on the ecosystem itself, or you consider the margin and everything as part of the ecosystem. It either enters the soil or it runs off, and the timing and the quantity of the water flowing into Puget Sound is critical to what Puget Sound is going to be like, okay? Any pollution that moves along with it, particularly things that might mimic hormones in fish and mammals, can be filtered out by soil if the water moves through the soil and not over it. Key is to try and keep soils forested. Forested state is probably the best because that growth of the forest encourages all the positive aspects that I'm talking about. But where areas have been urbanized, we can do things that can start to regain some of the properties that are more closely associated with forest land. And thank you.
So our next speaker is going to look at things from a First Nations, Native tribal perspective, is Terry Williams, who's a commissioner in the Tulalip Tribes Office of Treaty Rights. Terry.
Okay, thank you. It's a pleasure to be here today. In this process on Puget Sound, following the current rules, we're not getting there. And after almost 30 years of working on the landscape, it's become abundantly clear what we're doing as a society and structured around governance is our governance has gotten locked into this kind of no net loss approach where we don't really have to go back and have solid reference points. Let's just use the information we have today and look forward and try to find a new future that way. Well, that's not working. And I can tell you from the Tulalip Tribes, we actually created the watershed planning process for the Puget Sound Water Quality Authority back in 1987 when that was adopted. Subsequent to that, we developed a watershed analysis. We developed a lot of the landscape approaches, including flows, and actually did the first climate model for Puget Sound. We've been busy working at the science because one of the things we've learned is if you can't back up our thinking with solid science, we're just not going to get there. Unfortunately, this science takes a long time. And I know for our members of the Snohomish watershed here, we've invested in the last 7 years with the partnership a tremendous amount of money in the recovery. I think bouncing around the $50 million mark when you count direct grants and other contributions. But we're not keeping up with the recovery. There's a few things involved. One is the local protections aren't in place, whether it's in forestry, ag, or urban development. And the other is that the science that we're using is using basically today's standards. And what we're seeing in the lack of that is no net loss does mean we're starting with a degraded landscape. And that means that when we do our restoration, we're starting from a shallower portion in the well than a robust level. And I think what we need to get to is more like the presentation you just saw on soils. What we're missing is that piece of the soil that used to be on the landscape. There was a time when we had old growth timber from the crest of the Cascades on down to Puget Sound. And when we had that, we had duff on the ground. It would range anywhere from 15, 18 inches on up to 3 feet deep. And when you saw the slide, it shows how water moves through the soils, how it moves across the surface. Moving through that duff was a great buffer. We also had a lot more wetlands in place. Wetlands started disappearing around the time timber started being harvesting. It was quite a coincidence. But the thing was, you know, when people decided that this landscape was more important to economic values rather than Forest Services values, we started losing our future in terms of our own values. What's important to us? And I can tell you, working for a tribe now for 30 years on Puget Sound, I went to my tribal council a year ago and told them that if we don't find a way to change the rules, to change the process, within the next 20 years, we're not going to have a culture to practice. The species that we're tied to on the landscape aren't going to be there in abundance if they're there at all. You know, the landscape is going to be different, it's going to look different, it's going to function different, and it's not going to function in a way that supports tribal life. That's what's critical here. And for a lot of you who are sitting here debating whether or not these are the problems, we have people out on the landscape every day trying to make a living and practice a culture in it. And they tell us directly what's wrong. And it's not just recently. In 1995, the Clinton administration asked me to go open an Indian office at EPA in Washington, D.C. And the administrator, Carol Browner, asked me to walk the landscape and look at the problems that the tribes needed to solve to improve their livelihoods. And I walked the ground from coast to coast. In the first 18 months, my staff said I put on about 150,000 air miles just getting to reservations. And everywhere I went, this is before the tribes were organized in environmental issues, everywhere I went, the people said that the United States just does not know what they've done to themselves. We started out in the state of Washington looking at salmon. And one of the things that we saw was that the salmon can't live here because the whole environment's changed. So we set up programs to start affecting that. From the authority to timber, fish, and wildlife, to agricultural approaches, to urban approaches. And it just wasn't enough to get there. And that's what the tribes are saying nationally, that when the U.S. came through and harvested this country, they didn't replace it. 90% of the soils in the Midwest were gone, the things that the buffalo fed on. 90% of the old growth or more in the Northwest was gone, and it wasn't replaced. The soils underneath the old trees were gone, the logs, the vegetation that piles up, the animals, the birds, the fish, everything that brought nutrients to the soils were in low abundance. Fish bring nutrients from the ocean to the soils when they go up to spawn, animals, birds, bears, wolf, coyotes. They drag these things out and feed on them, and then they spread their waste throughout the watershed. That isn't happening anymore, not in the abundance it takes to regenerate. So we have a starting point of a weak system. And most critical in that, to me, is part of that water retention. I mean, watching these slides from the previous presentation really hit home to me, because that's exactly what I'm talking about. When we look at, it wasn't just the duff that helped slow it down. There's also other larger vegetation from trees that fell down to branches to other types of heavier objects. Large trees, when they fall over a period of time, they turn into big sponges. And if you have a tree with a diameter of about 3 feet or so, and it's been laying on the ground long enough, that holds thousands of gallons of water. And it seeps out over time. And in the summer, when we're in drought, that's supposed to be there seeping out to feed the soils around it. They're not there anymore. The duff isn't there anymore. We have compacted soils in the forested area. We have them in agricultural areas. We have them in urban areas. There's not a whole lot of difference. I've gone out on the ground with our biologists doing stream surveys in the upper headwaters. And when it starts to rain, we were out one day and we were in water up to our knees, just looking at the structure, what was on the bottom of the riverbed. And within a 2-hour period, it was up to our waist. That's quick runoff. That's what we have to start addressing, is how do we turn that around? What are the types of things that we can do to make a change, to make the forest healthy again? And not only is that vegetation in that duff, vegetation that slows water down, it stores carbon. So as we start looking down the road into doing a counter to climate impacts, the more carbon that's on the ground, the more we're going to be able to compete against the change that's already upon us. We met with the Alaskan natives just a short while ago, and they were asking us about this animal that came up into their territory. They were trying to figure out what it was, and they described it. And one of the guys in the group says, "That's a beaver." And he's right. It was a beaver. It's just that it was so cold in Alaska in that area before, beaver never went there. Robins are up there now. We have squid coming up from Southern California off the Washington coast now. We have hake coming from Mexico, clear up into southeast Alaska. The changes in the ocean temperature, the changes on the forest floor have made significant amounts of alterations that we now have to sort out how to live with. And that's okay if you can migrate and follow your species, but tribes can't. We're nailed to the ground through federal law. Once we step outside our boundaries, we're no longer Indian. That's the issue that we have to face right now. And as we're watching species disappear, as we're watching them migrate, as we're watching the forest change, we're watching our culture disappear. And then we look to see what the rules say. One of the rules was NOAA said they did a forestry HCP. Well, they did do one. For looking at recovery, it wasn't anywhere near what we need to see recovery in the forested zone. And I think a lot of the industry understands it now because they're selling their lands, and insurance companies are getting them, housing development's getting the land. Everybody's getting the land but large foresters, they're leaving town. Agriculture. We got a 15-foot riparian paid for by NOAA and some other perks, but basically that was it. Urban development. We have an urban HCP. I haven't seen one implemented yet. I saw Seattle try to implement one, King County. They got sued. When it comes to looking at the Puget Sound partnership, the amount of land that they can actually affect is a minor percentage of this basin. And when they try to affect that minor percent, they got to be in a no net loss zone. You know, it isn't going to work. We have to start looking at what do we need to change to get to recovery? And do we need to be stuck in a box when we know the box isn't designed to function? Now, I've argued with the federal and state agencies about what they can do. And I work for a federal agency, and I know they have a lot more discretion than the law allows for. The administration gives them a way out of a problem, and they're afraid to take it. They're afraid to take the way out that makes sense because somebody might sue them. You know, if this is the way we're going into the future, we're in trouble. If we're going to start dodging and dancing around every potential lawsuit, the reality is we have to restructure the way we see our future and the way we want a future. And I can tell you the tribal folks want a future. We've got our kids to look for, to look out for you know, where they're going to head. And so the first thing we're telling the federal agencies is use your discretion. Look at the models that we have today, and then do an old growth layer on top of that. See what's missing. Find out why the water runs off so fast. Find out why it doesn't get into the ground. And do recovery to make that work. Right now we have great recovery projects. I think our watershed groups are doing a terrific job on identifying problems, on identifying restoration projects, and identifying next steps. They just don't have all the tools to make it work and function appropriately. They have to be more robust. For every restoration project we do, we should have a layer of duff on top of there that helps slow that water down. I mean, this is silly. And it should be obvious. The other thing is engage the public. When Bill Ruckelshaus started this process, even before the partnership and the shared strategy, one of the first things we told Bill was if we're going to, as tribes in Puget Sound, support the process, you better have a process of accountability. The things that we do need to be measurable. The amount of money we spend should be accountable in knowing what we're going to get out of it. And we need to see results. And he says, if that's all you want, you got it. We've not seen it yet. In fact, the committees are just now pulling their goals and objectives together. They're just now starting to figure out what they're supposed to be doing and how many years are we into this. I mean, 30 years of wandering, through the Puget Sound Basin is getting a little bit intolerable. This doesn't make sense anymore. We started out with water quality problems in Puget Sound. Now we got whales floating belly up. Does anybody really care? I mean, is that a problem or not? Somehow, we've got to be able to step up and say, are we making the right decisions? Are we going the right direction? Do we have the political willpower to take the next step? And I know for this type of a session, this isn't probably what you expected to hear when you came here, but the reality is we got to do something different. We need to be, what I heard a lot of the people early on in the recovery process say, we have to be bold, we have to step out, we have to make a difference. I'm not seeing it. Where are the people that are bold? If they're bold, where are they? I mean, is it bold to sell your property and move out of town? Call up Noah and say, I don't know who's got that HCP, but it's getting developed. Maybe you ought to take a look at it. This isn't right. And I think, I made a commitment to myself and my tribe to try to just be straightforward. And I'm not saying anything that people in here probably don't already know. The only difference is I'm saying it. And I hope that after we get through with today's sessions and after we get through with the discussions, that I won't be the only one saying this, because we do have to make a difference. I want to thank you for your time. Thank you.